Welcome to ERDC Live. I'm your host, Shelley Tingle with the U.S. Army Engineer Research and Development Center. Today, we are joined by Dr. Ty Walmsley and Dr. Julie Rosati to discuss the world of civil works research and development and why it is so essential for our nation. Dr. Walmsley, who has been a guest on this show before, is the director of ERDC's Coastal and Hydraulics Laboratory, or CHL. Dr. Rosati, also with CHL, is the technical director for Civil Works R&D, focusing on flood and coastal risk management. Together, they are among the U.S. Army Corps of Engineers leaders in Civil Works R&D, from mitigating the impacts of climate change on our infrastructure to promoting sustainable construction materials. Civil Works R&D is making strides to ensure the nation's structures can withstand extreme weather events and support future generations. But it's not just about bricks and mortar. Civil Works R&D is also about preserving the environment and protecting our natural resources. USACE is using advanced modeling to better evaluate beach nourishment alternatives and assess flood-related impacts. It's all about making informed decisions that benefit our communities. Dr. Walmsley and Dr. Rosati, thank you for joining us today.
Thank you.
Good morning.
Good morning, Dr. Rosati. So today's discussion obviously is focused on Civil Works R&D and is a general term for our conversation today. Dr. Walmsley and Dr. Rosati, how would you describe Civil Works R&D and the role it plays today?
Well, I guess I'll jump in first. Civil Works R&D is really all about and ties back to our Civil Works mission of the Corps of Engineers, which is about navigation, flood risk management, and ecosystem restoration. And so everything we do within Civil Works R&D is really about delivering that mission better. And by better, using new techniques, new ways of doing things, and being able to do things faster, more efficiently than we've ever been able to do them before, and really making them more cost effective. And I think that the unique thing about Civil Works R&D and R&D within the Corps of Engineers is really there's a focus on applied research and technology transition. So we do a lot with partnerships, which requires a lot of us to do a lot with partnerships. So we're scanning the S&T horizon, looking for the best technologies and ideas that are out there, and then how do we take those and then apply them for the specific challenges that the Corps of Engineers faces. And so in that realm, a lot of what we do, and I think another thing that's really unique, is about half, ERDC is the execution arm for the Corps of Engineers Research and Development, and about half of the portfolio is actually funded by projects. And we take the technologies, the methods, the tools that we develop, and we apply them on real-world projects to provide benefit to communities and to our nation, on the ground. And then that, of course, then feeds back into our research and development process as we get that real-world experience with things. So very much a focus on tech transition, real-world application to make our nation safer and better.
Thank you. Dr. Rosati, what role do you see as technical director of Civil Works R&D? What role do you see R&D playing?
Yeah, I think what Ty said is spot on. Part of the partnerships that really benefits us is working with graduate students so that we can educate them and help them be part of our future hiring source. So that's part of what we try to do too. So it's all about demonstrating and getting those higher education folks to be part of the solution, and they understand the public service aspect of what we do in Civil Works R&D.
Very good. So I'm going to focus now a little bit more on infrastructure. So how is R&D reimagining the ways we build and revitalize our country's infrastructure components? And how does climate change play into this new way of thinking?
I'll start again, but you jump in whenever, Julie. The Corps is facing a lot. We have a huge backlog of projects that need to be done, construction as well as operation and maintenance. And we're in kind of an interesting place in our nation where a lot of infrastructure was built over the last 150 years. And now a lot of what we're doing is how do we extend the life of that? How do we repair and replace this large infrastructure? There are still some very large construction projects that are happening, but how do we, it's really more nowadays about how do we extend the life of those things. So there's a lot going on in the context of infrastructure that's really related to that. Things like structural health monitoring, for example, where rather than looking and kind of waiting for a schedule to say, well, this thing's been around for this amount of time, it's time to take a look at it and see if we need to see if there's a problem, or waiting till a problem actually occurs. Developing technology that's constantly monitoring, using the latest in sensor technologies, integrating that with modeling, so that we can really understand the condition of the infrastructure using the latest technology. And then with that, we can then combine that, basically creating a digital twin of the infrastructure, where we're kind of integrating all this information together, from the monitoring of the operation of things, the things that are going on the ground, and that these digital twins can bring all this information together that's also sensed through structural health and monitoring techniques and things like that. That really then supports decision making about how we operate the technology, and then also is going to provide feedback on how we can better design, extend the life of, or better design new infrastructure that may be of a similar a similar type of infrastructure.
And I think that that's a great example of how we do things here at ERDC, or how we do R&D here at ERDC. Is not just CHL. It's not just Coastal Hydraulics Lab. The example that you just talked about, you're involving structural engineers, you're involving IT people here at Information Technology Laboratory, and so it's bringing in all the experts to the table and different backgrounds to solve things like structural health monitoring, because we know that we cannot afford to replace all of our infrastructure at one time. We've got to extend the life, and then learning that information, having the digital twins, is going to save time and money in the long run. So thank you for that. So ERDC is talking about construction materials. ERDC is studying construction methods and materials that assist in sequestering carbon, helping the climate. Can you tell us more about the specific measures being taken to reduce emissions and promote sustainability? So, Dr. Rosati, can you answer? I'll go to you first on sequestering carbon. What are we doing in that area?
Yeah, that's a real big question. As Ty mentioned, our portfolio of infrastructure is so large in the core that we're really looking to extend the life, because concrete and cement have such a carbon footprint that if we had to replace everything, it would be a large impact on the climate emissions. So we are looking at innovative methods, whether it's hybrid infrastructure solutions with engineering with nature and nature-based solutions, along with the built infrastructure to provide that buffering and extend the life, and maybe even change future operations and maintenance requirements or design of new infrastructure, as well as looking at low carbon and carbon sequestrating cement and concrete materials. Our GSL team is working with other federal agencies to define better standards for how we inform industry of what we need in the federal government to do that reduction of emissions. And those engineering with nature and nature-based solutions are really innovative and out of the box, from printing different types of nature-based solution structures, 3D printing, to provide that that kind of integrated approach to using materials in a different way and reducing the hazards and extending the life of the built infrastructure systems themselves.
Thank you, Dr. Rosati. Do you have anything to add to that?
One thing I'd add there, and this is an area where, the challenges of the Corps of Engineers are kind of unique, and this is a place where Civil Works R&D really, I think, has to kind of jump in, because there's a lot going on in this space in industry. There's a lot going on. It's moving towards more using sustainable materials, using new, and I don't know the technicalities of this stuff, but using new cement mixtures and things like that have a lower carbon emission footprint and all of that. But what's going on in industry is things, your more typical roads and bridges and things like that. In the Corps of Engineers, we do things on a scale that is much larger than your typical things that are going on. And so one of the things that I think we can bring some value to is in these mass concrete situations where you're pouring these massive structures. How do we dial in and get it right for those so that we can utilize and integrate these sustainable materials in a way that doesn't compromise designs and things that aren't done typically done out there in the larger market. And so again, it's kind of bringing the science and technology that's going on in the larger S&T landscape, bringing that in and applying it specifically, looking at the challenges that the Corps of Engineers faces, which is quite unique in a lot of situations.
And it's a little bit like Dr. Rosati said too, of having those specifications in place. So we know based on industry that there's a lot of things going on with sustainable materials, but that doesn't necessarily mean that it's in the specifications and that we know that it will work on a large scale.
Right.
So that's where ERDC steps in, does the research and development, and works with our partners to come up with these new designs and new specifications so that we can integrate sustainable materials in all of our construction moving forward. So thank you. Another broad topic in USACE's mission is water management, from overseeing navigation to mitigating flood risk. Could you share examples of R&D efforts in these areas that are providing promising results? And I'm going to go to Dr. Rosati first, that she's the technical director with flood risk management, to start off with this question.
Yeah. Thanks, Shelley. Within that broad category of water resources, we have navigation, flood risk management, aquatic ecosystem restoration, but it also touches on hydropower, water supply, recreation, regulatory. Pretty much everything we do in the Corps of Engineers touches water resources. And some of the challenges in the area include things like we're seeing changing in climate and the forcing that is impacting that water resources mission in all areas, all those mission areas. And many times the solution that really solves one problem may not solve another mission, support another mission. So if you have a really great hydropower solution, but it may not be a great solution for the ecosystem, for example. So some of the R&D tools are trying to develop ways that you can look across the mission space and understand the impacts and the optimized solution that really gives you an alternative that supports a broad mission across the portfolio and lets you make an informed decision. So you understand the flood risk benefits, but also the hydropower benefits or the ecosystem benefits related to that solution. Within FRM, some of the things that we're doing include the coastal hazard system, which is a database of historical and potential future impacts in the coastal region from tropical cyclones and extratropical cyclones impacting communities and on the coastal zone. And that helps us do some of our planning studies that are really constrained in time. You have this database, you could look it up, the solution, and be able to use that to force your numerical models. We're looking in the future to do something like that for the inland system. We call it the inland hazard system. It's not supported in funding yet, but we're looking to grow a similar inland hazard system database so that we can similarly streamline these types of analyses and inform the hazards that are going to be impacting and looking at those types of solutions. The final thing I'll mention with respect to flood risk management is about the hazards that we're seeing are not just one hazard at a time. We're seeing compounding hazards, so they're not just one storm, but it may be a storm that also comes with a major river influx hitting the community that, like you said, are on the coastline that is really impacting the communities in that area. So we're seeing a lot more of these compounding hazards and the impact on those hazards on the communities that have to deal with the response. So there are a lot of areas I think that R&D can serve in the water resources mission area.
So do you have any specific examples of some of the recent success stories in this R&D space?
Yeah, I think, one real big area that we've made a lot of progress is in engineering with nature. Of course, we've been working very closely with partners for engineering with nature in demonstrating successful technologies. And now we are starting to work with headquarters to develop guidance for how do you design these features so you know how long they're going to last and what is their maintenance requirement over many years. And so that's some of the areas where we've made some progress, but we have a lot more to do in developing that engineering guidance. Another area that we've really done a lot of navigation mission, looking at using artificial intelligence and machine learning to optimize the dredging fleet, and where do we need to go to dredge our channels, and what's the optimized solution across the portfolio for the Corps, instead of just doing it piecemeal, district by district, looking at an integrated approach and using the science and technology to really guide those decisions at the headquarters level, at the portfolio level as well.
And so I want to remind our audience that while this is, we have a lot of hot topics today on civil works, and so you are part of the conversation. So if you want to ask Dr. Walmsley or Dr. Rosati a question, just put it right there in the comment section, and in a few minutes I will be asking them your question. So Dr. Walmsley, we are seeing sedimentation issues involving many of our lakes and reservoirs, where increased sediment is reducing water capacity and causing downstream issues. What is being done to address this challenge?
Yeah, that really is a big issue, and of course sediment is a big issue, and one that the Corps of course deals with a lot. Hence the massive dredging budget. But in particular with reservoirs and reservoirs filling in, which of course has an impact on our flood risk management mission. As the capacity of those reservoirs is diminished. We're looking for innovative ways to try to deal with that. And one of the more interesting ones that's going on right now is a water injection dredging project that we're partnering with the Kansas City district on. So we're developing some things on the R&D side within our dredging operation and engineering research program, environmental research program, and we're looking at developing a water injection dredge that what it does is it injects fluid into the sediment, and the way at this Tuttle Creek reservoir, the gates are at the bottom, and so if we inject this fluid into the sediments, it creates what's called a density current, and so basically you have this dense sediment infused fluid that then starts to move itself. It pushes itself along the bottom and can then go through the idea is it then goes through the dam gates and into the downstream side. So there's a lot of research that needs to be done and that needs to be done in technology development to make this happen. So we're actually doing some work in our physical modeling facilities now, looking at, hey, how do you design this water injection dredge? This would be the first project like this ever done in the United States. How do you inject that fluid in there? So there's a lot that's going on within that realm. And then you also have to do some research on, hey, with all this sediment now going down and into the downstream side, what are the environmental impacts of that, and how do we deal with that? And so again, another example, as you were talking about before, where we've got folks from our environmental lab, our coastal hydraulics lab, folks out in the districts, all working together to solve this problem. Because
like what Dr. Rosati said, you have to look at it holistically. Just because you solve this one problem doesn't mean that you're going to cause another problem somewhere else.
Right.
So you have to step back and look at the big picture. So staying on the topic of sediment, USACE has set a goal to place 70% of dredged sediment in areas where it can reestablish ecosystems, nourish beaches, and increase coastal resilience. How is ERDC leveraging its R&D capabilities to support this effort?
Yeah, the chief has set that goal of 70% beneficial use by 2030, and that's our, as Ty alluded to, that's our biggest ticket price in the civil works mission space is dredging and placement of dredge material. So if we can do that in such that we create value with the placement of that material, will really impact the Corps and communities too, and the public. So we're doing some really innovative ways of looking to place the material such that it creates an environmental asset. There are a couple of activities. One is a perforated dredge pipe, such that we can control the distribution of sediments onto vegetated low-lying wetlands, and use that pipe to help distribute the finer grain material, because the coarser grain will settle out earlier in the pipe, and the finer will continue on and be carried further at the end of the pipe. So that's a way that we're looking to optimize the transport and distribution of sediments and develop guidance for that. We're also looking at nearshore placement of sediment. So that's a form of engineering with nature that lets us put material in the nearshore coastal zone and let nature move it onshore to provide a coastal storm risk management benefit for the beaches and the dunes to reduce our flood hazards as well.
So do you have anything to add? I know your background's coastal.
Yeah, no, I mean, there's a lot. Of course, there's a lot going on in this area and how we do this. One of the things that we'd like to do as part of our plans in doing is to utilize some of our facilities here to actually and work closely with the dredging industry on innovative ways of actually placing material. Mm-hmm. So, and this is really closely tied to our engineering with nature. So how do we, and design, developing design guidance. It's, we know that all these various features provide some value of benefit, but how do you build these things? How do you place the material so that you maximize that benefit? And there's just this area is just so wide open. For research, it's really unbelievable. We even need to better understand sediment transport, our sediment transport algorithms and things like that. How do we improve those? How do we better parameterize the sediments that are out there? Because each and every sediment's a function of the environment that it's in, and so there's a whole lot of work in terms of instrumentation and measurement and things like that that's got to be done. And so. Big area, lots of interesting things going on. We're also doing things like we've developed a tactical dredge that allows us to do very small things in a more tactical, small way that'll allow us to get into areas that you can't get into with your traditional large dredges. That also, I think, will ultimately enhance how we are able to beneficially use more sediments and things like that on more of a repeat basis and things like that. So, kind of getting into that whole robotic dredge, and with the long-term goal being things like a dredging Roomba that's just out there kind of keep maintaining things and placing material and keeping the sediment moving through the system that supports these beneficial use goals.
Very good. So how is Civil Works R&D working to address environmental justice concerns and ensure that no group bears a disproportionate burden of environmental harm and risk?
You want to take that?
Yeah, that's an area that we're looking to incorporate aspects of environmental justice across our products and programs so that we understand how we can benefit that area. Just so everybody's on the same page, the environmental justice refers to the fair treatment of people with respect to our environmental laws, regulations, and policies, which is pretty much everything that we touch in the Water Resources Mission, because what we do in the environment touches all the communities and people. And so what we're looking at doing is looking at the human health and environmental impacts, including the hazard impacts on all the communities that are impacted by our projects. And so our tools are trying to bring in those metrics and measures as we can to be able to look at the hazard, whether it's a wildfire or a coastal storm or hurricane or flooding or pollutants even. Some of our harmful algal bloom work that we do definitely impacts communities, but also then the cumulative impacts of those hazards too. So you might have, like we talked earlier, you might have a riverine flooding with a coastal storm, and you may have some pollutants in that water that floods a community. And how does that then impact? And what are some environmentally justice mitigations that we can do to reduce that hazard and the impact on vulnerable populations? So we're looking at not only those kinds of hazards, but other things like noise, pollution, water supply, and drought as well. And what are the best ways to be able to develop consistent metrics across our tools that we can make informed decisions about the impacts and ways to mitigate those hazards on those populations.
Thank you. And so right now we're going to go to our audience questions. And so if you have a question to ask Dr. Walmsley or Dr. Rosati, put it right there in the comments. If you are just now joining us, I am here with some of the leaders of USACE R&D's Civil Works program. And so if you have any questions related to that, put it right there in the chat and I will ask it. So our first question is about what Dr. Rosati just finished talking about, where she mentions wildfires. So the question is, with wildfires becoming more intense and frequent, post-wildfire flooding and debris flows are a growing concern. How is Civil Works R&D developing methodologies or modeling techniques to assess and predict the risk of post-wildfire flooding?
Yeah, that's a great question. Yeah, we've had some work in that area for several years, and Dr. Ian Floyd is the lead at ERDC for that, working with the Institute for Water Resources as well as state and local agencies out west and academic partners to look at the tools that we have and modify those tools so that we can predict that debris flow. And after a wildfire, the surface of the soil changes consistency in the way it responds to flooding after that. So precipitation hits these parched, arid regions that have been impacted by wildfires, and that mobilizes sediment in a different way that's more like a honey or molasses response, and it can bring a lot of debris with it, a lot of trees and that don't have the root structure anymore, that are very damaged and burned. So all this debris, sediment, and burned wood and all that comes into these communities can really impact the infrastructure as well as our missions in the core, navigation, the reservoir capacities, and then ecologically as well. So it's not only a safety concern for the communities and the populations, but it really impacts our mission space. And so what Dr. Ian Floyd and his teams across the Corps have been doing is working with the federal agencies in those areas, as well as the state and local agencies, to develop these tools and then transfer them to practice so that communities can use those tools and be able to predict where are they most vulnerable to those hazards and develop some, or they might be impacted by a wildfire to offset some of those potential damages.
Thank you. And so our next question, I'm going to give this one to Dr. Walmsley. What are some of the specific projects or technologies that CHL has been involved in to enhance water supply management and protect the environment as part of USACE's Civil Works mission?
So water supply?
Water supply management.
Yeah, so of course, we do a lot of development in terms of our numerical models, our ADH model, our numerical models for looking at flows. One of the more recent areas that we've been working on, and we've been doing a little bit of work with the Mississippi Valley Division on this, is on some groundwater sustainability things, where we're looking at the interaction of surface water and groundwater, and how can you move water across watersheds to really kind of enhance the sustainability of of our aquifers and things like that. This is an area where we do some work. We don't do a lot. Water supply is it's not part of the navigation flood risk management. I mean, it's connected, but it's not directly related to kind of our core missions, if you will. But we've been doing, but really in terms of technology development and looking at aquifer recharge and manage aquifer recharge, we have been doing a little bit of work in that area.
Very good. So how is Civil Works R&D finding innovative ways to quantify the benefits of natural and nature-based features? What impact can this have on the implementation of NNBF in future projects? So how do you quantify those benefits? I'll go to Dr. Rosati first.
We've been doing that for beaches and coastal dunes for decades, right? We know how to predict the performance of a coastal storm risk management and dune system. And so we have tools that exist to look at the life cycle over decades. We know we can run all these different storms and look at different dune heights, beach width, elevation, et cetera, and look at the best solutions for that. So what we need to do then is transfer that to other types of nature-based solutions like living shorelines or wetlands or riverine features and that sort of thing. So what we are doing is we're doing some lab work. We've looked at mangroves, type of feature that particularly in more tropical climates. The Florida coast has some, and Louisiana has some as well. Looking at the performance of those so how much do they reduce the water levels? How much do they reduce the waves? And the other piece of that is then monitoring them in the field and their life cycle performance. How long do they last? And how fast then quickly, how effective are they? Or if it's a really slow moving storm and the water level rises slowly, they may just let that wave go through and not reduce it as much. So things like that, we're looking at the performance not only in the lab, but also numerically and in the field. We've got several demonstrations at field sites as well.
So how do you communicate those benefits when someone asks you things like, what is the return on the investment? How do you begin to quantify that?
Yeah, it's tough to do, but as Julie mentioned, we've been doing this for a while with beaches, and so and one of the things that we're working on now, and that technology has been around for a while, where we actually tie the physical processes to the economics of it. And we've done that with beach nourishment. We've had technology called BeachFX. It's been around for quite a while. And we're right now in the process of updating that, improving and integrating it with better coastal processes models, utilizing, we talked about the coastal hazard system before, and all the and that's all of this hazard information within a probabilistic framework that can then be ingested by models that look at things, and it's probabilistic life cycle modeling. Because the challenge with all of this, of course, is that these natural and nature-based features, they change over time. They can recover. They can be damaged, and so you can, and that is going to be a function of weather, of the forcing, of the hazards that happen. And so you can't just run, okay, we're going to run out 50 years and say, okay, we know what's going to happen. We really don't. We have to look at multiple life cycles of this. And in doing that, then integrate that with the economics at the same time. And so this probabilistic life cycle framework that we're working on, first will be applied to beaches, as we've done with some of our older technologies too, but it's being done in a modular way, so that it can easily be upgraded and plug in different types of different types of natural features and things like that can then also that then works with the overall framework to really get at, okay, what is the benefit? What is the economic, what's the economic impact of this? What are the damages that we're looking at to some of the built environment that we're looking to protect, or perhaps even the environmental environment that we're looking to protect as well, and attaching values to that. So there's a lot going on in this area. It's a very complex area, but and again, another great area of research where we have a lot of work going on.
And we have so much data.
Yeah.
Because we've been
But we
doing
always
this
need
for a
more
long
data.
time.
Yeah, we always need more data.
Always
though.
need more data, but it is like you said. You've been doing it for the beach side of this for a really long time.
Right.
And so applying the lessons learned that you've already done, applying that across the board, so we can better identify those benefits and be able to communicate. If you invest in this, this is what your return is going to be, and educating our nation about those topics. Next question, how is Civil Works R&D partnering with academia to develop effective methods for aligning biodiversity conservation with infrastructure development? So the first part of the question asks about how are you working with other partners, and the end of the question is about aligning the biodiversity with infrastructure development.
We
I
work
can
a lot. Go ahead,
Go
Julie.
ahead, Ty.
Well, I was just
okay.
go. Okay. Yeah. I'm fine.
We're going to let Dr. Rosati answer first.
Okay. Yeah, we work, with partners very frequently and extensively. As Ty said, about half our portfolio roughly is partnerships with academia and industry and other federal agencies as well. One of the ways we do that is through broad agency announcements, where we have a solicitation that's open all the time, year-round, for ideas on any topic. We also work very closely with ERDC Works, who is a intermediary that helps us partner with other academic and industry groups for different solutions to problems. So there's a lot of ways that we can partner with others, and we're always looking for ways to do that better and faster to address these challenging national problems that we have in Civil Works. The second part of the question about the biodiversity and integrating with infrastructure solutions, part of our Engineering with Nature program and other Civil Works R&D look at the integration of those types of solutions, what I mentioned earlier, hybrid solutions. How do they perform? Because there could be real benefits in that a natural solution might provide a reduction in hazards for some more higher frequency events, more typical events, whereas they wouldn't work real well if you had a big storm. So maybe you have a built feature to supplement part of the hazard problem. So they kind of would work together in concert. And so our numerical tools that we're developing under many different programs for different types of problems are looking at those integrated hazards and the solutions that we can provide with the hybrid natural and built infrastructure solution.
Very good. Do you have anything to add to that?
One of our strategic focus areas in Civil Works is on ecosystems and sustainable species management. So how do we deal with harmful species, which of course harmful species, as well as how do we enhance our threatened and endangered species as well. And so we've got some work going on in next gen ecological modeling and things like that. We're doing a lot of work in the area of harmful algal blooms, which of course impacts the biodiversity that we're dealing with in our ecosystems as well. And so there's a lot going on in that area, as it's one of our core missions, of course, is to enhance ecosystem restoration. So that biodiversity of the species is really important and a focus of one of our focus areas within Civil Works.
And that's one of the things about the Civil Works R&D program is, again, a lot of times when people hear that, they think of a hydraulic engineer or maybe a structural engineer. It also involves research biologists and chemists and other fields of expertise to think about the solutions for HABs.
Right.
It takes a lot of different types of specialties at the table, which is what ERDC does best,
right,
of bringing in a wide variety of people, not just here, but also, like the question first asked, academia, industry, other government agencies. we're known to bringing the right people to the table to help solve the solution. And so our next question is about fiber reinforced polymer composites. So can you talk about ERDC's use of fiber reinforced polymer composites to extend the life of infrastructure? And so this kind of goes back to the beginning of our conversation when we talked about we can't replace all infrastructure at once, and how do we extend the life of a lot of the infrastructure that's already past its life cycle?
Yeah, there's a lot of potential in this area as we look to repair and replace a lot of our infrastructure using these new materials. And so within our NAVSIS program, we've done a lot of work looking at these and developing these technologies, working a lot, of course, with industry. And really, the time is now ripe to really start to move and to put these into practice. That's kind of where we're at with a lot of this. The biggest challenge that we have in this, and this is kind of where we talk about a focus within our R&D program and tech transition, is we've got to make sure that this stuff gets into the guidance and that we fully understand how these different materials perform in the field. How do we repair them if there's a barge impact and things like that. And so there's several projects out there where these are starting to get into practice. One of the first ones we did was some wicket gates up at the Peoria Dam, and another dam up on the Illinois Waterway. And in fact, there's just been a project done where they're constructing 200 of these to actually put them into place, into practice. So the first ones we built within the R&D program, they performed well, and now they're moving forward and doing that and working with industry now to develop those to construct those materials. And there's other projects now that we have in the pipeline that are looking to use composites, and so look both composite miter gates, composite stop logs, tainer gates, and those things. And so we're working through some of those challenges now and finding who are we going to work with in industry to be able to do those, and working with our E&C groups in the districts to actually get those then put into practice.
And what's amazing is I've been following fiber reinforced polymer composites for a little while because my background is from GSL and some of their materials guys. And so what's fascinated me is how fast ERDC has been able to get this into the right hands of doing these miter gates. And now we've seen research to reality of now industry taking it, and now they're running with it. And what a great story of ERDC R&D.
Yeah. And Europe has really done. Europe's kind of really ahead of the United States on a lot of this, and so they've kind of led some of the charge on that. Of course, we have some of our unique things here, and so that's what we're working through. So Pete Steinovsky in our construction engineering research lab is really our subject matter expert in this area, and is doing a lot, working very closely with our INDC, our Inland Navigation Design Center. They are subject matter experts on this and really working hard to get composites and these composite materials out and into the field, and they're really championing a lot of this right now. And so this is definitely a combination of effort with partners across the globe as well as within the Corps of Engineers to make this happen.
Absolutely. So the next question is asking something that you brought up, Dr. Walmsley. It says, can the development of digital twins help with aging infrastructure? So previously you mentioned the use of digital twins. And so how is that assisting with aging infrastructure?
Yeah, Julie.
Either one.
Julie can jump in too, but absolutely. If you think about it in terms of essentially what a digital twin, at least the way I think of it in very simplistic terms, is I'm going to take all this data and all this information we have, and so a lot of these things that we got going on has a lot to do with big data and how we integrate that data together. And that's essentially what a digital twin is doing. It's taking these advances we've got in sensors and understanding what's happening and in the measurement improvements at the facilities. It's taking all the as-built information that we have, and so rather than someone having to go and flip through pages and look and understand, okay, where's this at in the structure and how do I get to it? It's all right there in a digital format. And so you're basically just integrating all of this information that historically has been in different locations. You may be able to put your hands on it quickly, you may not be able to. It's bringing new information to bear through these sensor technologies and things like that, and putting it all together in a framework, combining it with modeling as well to really just assist the decision maker. And that's really what digital twins is all about. It's about assisting the decision maker, giving them the information, more information, and in a format that allows them to better use their expertise in operating, rehabilitating, repairing, whatever the case may be for that piece of infrastructure. And it's really just kind of helping them pull all that information together and be able to get it to it faster and in a more efficient manner.
And in the end, that ends up saving money.
Absolutely.
Because you're not having to do iterations of what to do.
Right, and it can also help cut on downtime, which, so it's saving money both in terms of the cost of repairing and the cost of operating, but it's also saving, it's a big impact to the national economy if you think of a lock that doesn't, its downtime goes, is cut in half or even more. That's a big deal.
Yeah,
and
millions.
So, yeah, and that's a big economic impact, and so that's what all of this is really bringing to bear.
Absolutely. So there's another question. Actually, this is going to be for Dr. Rosati because she kind of mentioned this. How are researchers developing methods to quantify these broader benefits for USACE projects? So you talked about more of a holistic and looking at everything from a big picture and how one thing affects a different approach. So how will this approach impact future investment decisions and project planning?
Yeah, that's a big question. We are working across the laboratories in ERDC. So not only we mentioned a little bit about environmental justice and their social effects benefits, so how they impact humans, how the hazards impact the humans, but also we're working with our environmental lab how the ecosystems impact human health, well-being, mental health, and that sort of thing. And so we're trying to integrate align our tools so that our hazard tools can predict the hazards, but also then how do they impact those populations in terms of whether it's the ecosystem itself or whether it's the populations, with a filter to look at the vulnerable populations, those that are maybe disadvantaged historically, and also then those that may be more susceptible to some of the environmental impacts, whether that be pollution or the hazard itself, and the infrastructure that's in the area. So kind of integrating all that into one, just like Ty just said for the digital twin, one product that can let us make an informed decision across the portfolio so we can see the impacts of all those different areas on the particular solutions that we're trying to help communities co-develop with us for a particular mission space.
This is, to me, this is a very exciting area, and it's really something that's in its infancy. And Julie just mentioned one thing that I think is really key. It's co-developing these things with communities, because historically what we've done is this is all about attaching value, right? And all these projects are really, when you get down to it, they're about improving people's lives. It's about making the world safer, better, enhancing the lives of our communities, making them more resilient. And so, and historically, because it's something that we could do, that's all kind of been tied back to economics. Mm-hmm. Like if this piece of property, its value because someone is willing to pay a certain amount of money for it or whatever. And so everything kind of gets tied back to economics, but the value of something goes much, much deeper than that. And there's a lot of work that needs to be done and a lot of things that have to be worked out. But how do you truly value things? And the only way to do that is by co-developing it with the communities in which it is, in which it resides, because I think one thing, if you got a softball field in a low-income community, and someone from the outside looking, well, that piece of property, there's nothing there. It's just a ball field. It doesn't have the value of that is X amount because someone's willing to come in and pay that amount for that. Well, that ball field may have an immense value to the community because that's where the mentors get with kids from the low income communities and come together, and and it means something to the community that's much more than something you can see on a piece of paper or from
Absolutely.
some economic valuation. So how do you bring all that stuff to bear? And this is particularly important when we think about tribal communities and things like that. The value they place on things is very different from the values that we would place on those things. And so you've got to work with these communities to really understand the value. And our job in R&D is how do we now try to bring all that together and try to integrate that together so that it can then be utilized as we try to prioritize the activities of the nation and really maximize the value that we're producing for communities. So a really interesting area, something that we're just getting started on, but certainly one that is going to drive a lot of things as we move forward, I hope.
Yeah, I think it's going to really change the face of R&D over the next few years. Like you said, it's something new that we're doing, and I think it's very exciting to see how that's going to develop. So the next question is about droughts. So the western U.S. is facing lots of challenges in terms of water supply. Of course, we all hear about the droughts. Does ERDC have any projects that are helping with this challenge?
Julie, you want to take that one?
Sure. I think you all had Dr. Carrie Talbot on the ERDC Live before about the forecast informed reservoir operations, which is where we use atmospheric river forecasts to help us manage our reservoir levels a little bit more smartly. So if we know a big storm in, we're going to get a lot of precipitation, we can release some water and use it for those communities so that we have then more capacity for the storm. Water supply, as Ty alluded to, is not one of our core CORE missions. So we support the state and local partners in that mission, but our primary mission in that space is flood risk management. So we're looking to maintain our flood risk management, but that doesn't mean that we can't operate a little bit more smartly in using that really accurate information. And so Kerry and his team, he's working very closely with academic and local state partners on the FURO programs. They really demonstrate some success in providing more water supply to 22,000 homes in a very, very dry year. So that was a really big success for California several years back. I think the other area that Ty mentioned is it's an area I think of potential growth is the aquifer recharge options and solutions. And we do have some research that may get funded in the future to look at how we make aquifer recharge more of an option. There's so many unknowns there with water quality and how the geology and the characteristics of the soil impact the chemistry and the water quality. But, how can we make those decisions in a way so that we understand whether that might be an option for some areas of the country? So we do have a lot of potential there, I think. I think it's another exciting area in Civil Works R&D.
Yeah, and I should have brought up FURO on the previous question regarding water supply. That's the obvious one. There's a ton of work going on there, and it's a really great example of research to operations where we're working very closely with our the core districts, the water management districts, the local management districts, the states, everyone, bringing all those stakeholders together. And as you mentioned, I think there's been an article live on that before with forecast informed reservoir operations.
Just last month.
Yeah.
Just last month.
Yeah.
So if people want to go back and go to that event, you can click on it and learn more about how we're addressing that through FIRO. And so we've talked a lot about navigation and flood risk. And so this audience member wants to know, can you expand a little bit more on innovative ways to protect threatened and endangered species as it carries out the USACE mission? So you mentioned a little bit about HABs. Can either one of you expand on protect threatened and endangered species and also mitigating invasive species?
Yeah, as Ty mentioned earlier, we have next generation ecological modeling work that's been partnered with academia to look at both of those aspects. What's the impact on threatened and endangered as well as invasive species? We have a couple programs focused only on plants as well as critters for whether they're invasives and how they impact the navigation mission and muscle growth on our locks that really increases the wear and tear of our infrastructure. So there's definitely an integration of those spaces for those core CORE missions, navigation, flood risk management, and ecosystem restoration. And so some of the tools that we're developing in the civil works area look at, like I said earlier, it's a complex problem. You may solve a problem in one area. You might be really good in navigation, but it has a really bad effect on some of the threatened and endangered species. So our tools look at those overlaps and where we can do a better job at protecting some of those threatened and endangered species.
Another area where this is happening is actually funded through our Mississippi Valley Division. It's called the Geomorphology and Potamology Program. And so part of the work there is actually doing a lot of data collection and research and understanding some of the endangered species and how the operation of the Mississippi Rivers and Tributaries Project is affecting those. And so there's a lot going on there with, in terms of pallid sturgeon and various clams and least terns and things like that. And so a lot of work has been done in that realm, and that is managed out of Mississippi Valley Division, but a lot of that work is done by folks at ERDC along with partners in the divisions, the districts, the USGS, and others. And that's a really interesting program that goes on there that deals specifically with some of our threatened and endangered species on the Mississippi River.
So today we've talked about a wide variety of topics, everything from critters and plants to infrastructure and sustainable materials and sequestering carbon and flood risk management. So these are very different topics, but that is all under Civil Works R&D. And so I really appreciate both of y'all, both of you coming on the show today. And do you have any closing thoughts for our audience?
I would just say that, thanks for tuning in. We're very excited about what's happening in Civil Works R&D. The challenges in this realm are complex and vast. But it's really important to our nation, and so we've got a team of folks, and I'd just like to thank everyone who's working in, all of our technical directors, our program manager, and our PIs, because we have a great team of people that are out there working on this each and every day, and they bring a level of passion and commitment to it that really is inspiring. And so I'd like to thank all of them, and would encourage folks to reach out to folks for more. We've got a lot of information. We're working really hard on communication and getting the word out on various things that are going on. So there's a lot of resources on the web, and contacts there to learn more. And you guys could have had about 6 shows,
Exactly.
6 or 7 shows, and get the right, get all the subject matter experts in here to answer some of the really cool questions of the really neat work that's going on.
Absolutely. Dr. Rosati.
I couldn't have said it better. I think Ty said it all. You'll find that the people working in Civil Works have a passion to do public good and make the nation better, and that's really exciting. And it's not just ERDC; it's across the Corps, and it's with our partners. It's with academia and industry. Just this passion to really make things better and develop those really new ways of doing things. So we're really excited about Civil Works and looking to see it grow and change in the future.
And so we're going to end this show. I want to remind our audience that if you have any questions, sometimes you were watching this not live after we've already had the show. If you have any questions later on, just add it to the comments, or you can send us an email at erdicinfo@usace.army.mil, erdicinfo@usace.army.mil, and we will answer those questions as well. Also, if you liked some of the research you saw today and you're thinking maybe you want to come join the ERDC team, you can simply go to our LinkedIn page. There's a job section, and also on our website on how to work with us if you have research that where you want to partner with us. And so until next time, find your joy, and thank you so much for joining us.